Vance here. Have you ever wanted to blow something up? Well, I can't help you with that because that's illegal and pretty unhealthy. But I can show you how to do some pretty cool things with chemistry. Now, let's talk about why that just happened and how to make it happen again. That's fine. This speech will be split into two main sections. One is the chemistry behind this process, and the other is how we can make this cheap rocket fuel ourselves. So Board, if you'd come up here, please. And I'm going to start out this stir rod, and I'll have to periodically check in on it. So first, a question that you probably share. What the hell is going on? All right, so this is a Saturday, and no one wants to learn chemistry on a Saturday, so I'm going to try and keep this light. But there are two main elements, or compounds, that come into this mixture. One of them being potassium nitrate, and the other one being sucrose, or just plain sugar. Now, let's start out with our oxidizer. In this world, all kind of combustion needs oxygen to power itself. Now, here's the thing. The flames that you're used to seeing are starved of oxygen because air is not completely oxygen. It's only about 37%. The rest is nitrogen and boring stuff. So when you want to really make something that has efficient combustion and can work at high altitudes, like in space, you need a self-contained oxidizer. Now, as we can see here, potassium nitrate, we've got some juicy, unbound oxygen molecules. Now, these oxygen molecules can help with any kind of flame as long as it is a sufficient heat. Now, moving on to our fuel, we have sucrose, sugar. Now, as you can see here, these juicy carbon-hydrogen covalent bonds store up to 4 times more energy than TNT. And this oxygen helps to further fuel the reaction that causes this. Now, that might bring up the question, if sugar is so powerful, why am I not dead? That's a good question. Well, it's all about how energy is released. Explosives create a shock wave. They release a little bit of energy really fast. Combustives, which is what this is, they release a lot of energy, but they do it slow enough that it's not that dangerous. Let me check in on this. Now, when the fuel and oxidizer are combined and heated, this being a fire triangle, of course, with oxidizer, fuel, and heat, the sugar begins to burn. This burning is stimulated by the oxygen atoms here, which allows this to burn faster and release the energy contained in these bonds, because in our world, all energy is contained within bonds that are form or break really quickly. And then H2O begins to form using hydrogen and oxygen from various sources, which also stimulates the burning even faster, and it leads to this chain reaction that releases intense amounts of heat and light, as we just saw. Now, the unique violet color of the flame is caused by potassium cations, which are being charged by the energy that's just floating around. The electrons are being excited, and then they're returning to their ground state and emitting these violet photons. Now that we've skimmed over the reactions happening inside this propellant, we can move on to the next question. Why the hell is this happening? Well, there are 3 main types of rocket propellant: solid, liquid, and hybrid. But hybrid, well, that gives me a brain aneurysm to think about, so I don't really want to talk about it. So, this is solid. Now, solid rocket propellant is cheap, it's powerful, it's dangerous, and you can't turn it off once you start it. So it's best suited for when you need to get something really heavy up into space. If you look at photos of the space shuttle, or more recently the Artemis project, you can see those big white side stacks. That's solid rocket propellant. And if I were to draw a diagram here, very accurate as you can see, using some complex geometry, engineers are able to convert the heat and pressure of the gas released by our solid propellant into inertia, which, due to Newton's third law, propels the rocket. Now, finally, since we've explained the most important aspects of this kind of rocket fuel, and the stir rod has finished, looking good, I can show you how to actually undergo the process of making this stuff. Now, it's pretty simple actually. We just need to take our oxidizer and our fuel, stick them together in the right ratio, of course. I personally like to use a ratio of 61% oxidizer. You always need more oxidizer than fuel. Most of the mass in a rocket is actually just oxidizer, just to keep things running. And I like to toss in about 4% iron oxide, just to get that extra thermite fun in there, you know? Now, all you have to do is stir it. You gotta stir it thoroughly, because otherwise it won't burn correctly. And that's what we've been doing here. And so, as you can see, a fresh batch of highly potent rocket fuel. Pretty much high explosive. Now, this stuff can be pretty dangerous, so be careful. Now that you know just about everything anyone has any right to know about solid rocket propellant, let's review. I showed you how this stuff reacts. I taught you how it works, and I showed you how to do it yourself. Now, you've learned a bunch of pretty random, probably useless, but definitely interesting information today. So, now, if you ever need to understand how massive space launch systems work, or, make your own hobby rockets for cheap, now you can. Thank you.